guys, we are back, and today what we're going to focus on is Comtpia A Plus Certification Exam Core 1 Objectives. This is 220-1101. Remember, in order for you to become A Plus certified from the Comtpia organization, you need to go ahead and pass 2 exams. They like to go ahead and label it as hardware and software. The 1101 is dealing more so with the hardware component. There is bits and pieces of software, so to speak, and vice versa when it comes to the 1102. But nonetheless, we are on the networking subject. Okay, so we are on 2.0 for networking, and today's video is comprised of 2.4, where we're going to focus on summarizing services provided by network host. Now, before we get into the presentation, and this presentation is actually going to be quite simple, but do not look at its simplicity. Don't overlook its simplicity, because 2.4, okay, is basically married to 2.1. 2.1 and 2.4. Remember how I really emphasized 2.1? And if you guys watched that video, you guys really saw that I literally took like 3, 4, 5 minutes talking about the importance of 2.1, and you can see why, because 2.1 literally bleeds over to 2.4, right? Can you tell me the port number of DNS? Can you tell me the port number of DHCP? What about file share? What's the difference between encrypted and not encrypted? Can you tell me the port numbers for the ones that the protocol that is unencrypted? Can you give me the protocol that is encrypted? What about printer servers, mail servers? Hey, we talked about 3 protocols for mail servers, 2 of which was receiving email, one of them which was sending email. What's the difference between IMAP and POP3? So I'm throwing these questions at you. I'm throwing those jabs at you just so if you can get the answer right off the top of your head, and you're just like, I know what that is. I know what that is. Yeah, easy question. Easy question. That's good. Okay, that lets you know, hey, I'm studying. I'm doing what I'm supposed to be doing, and I'm actually going ahead and learning this material. Okay, but the 2.4 is like I mentioned, it's married to 2.1. Okay. Because these services, okay, this is one of the reasons why people have computers in the first place, right? Because the computer goes ahead and provides a service to make whatever you're doing out in your field, whether it be the medical field, whether it be the financial field, whether it be engineering, whether it be if you're running an auto shop, okay, more than likely you're using a computer and you're using these services. And we basically as technicians, we need to be able to diagnose those problems if those problems were to arise, or we need to be able to implement our knowledge, okay, to make sure that everything is working the way it's supposed to be working with regards to information technology. So nonetheless, we're going to focus on 2.4, and let's get to the presentation here. So let's go ahead and focus on, once again, we are on the networking subject 2.4, summarize services provided by networked host. Okay, so let's go ahead and get into the first one. DNS, domain name system. Remember, this is port 53. Protocol it uses is TCP/UDP. And remember, the whole purpose of DNS is to get a simple name like www.internet.com. Okay, because the humans like the name, and we're gonna take that name, and the computer is gonna there from that point, it's gonna convert it to an IP address. Remember, computers work in binary. Okay, and this right here is IPv4, IP version 4. It uses this format, so to speak. Okay, so just remember DNS. You go ahead and you take a web browser, you take a name, okay, and that converts it to an IP address, which lets the computer know, hey, I need you to go to this web server at this IP address and get these services, so to speak, or download files or do some web browsing. So that's what DNS does. Okay, let's go to DHCP. Okay, DHCP is Dynamic Host Configuration Protocol. We're looking at port 6768. Protocol that it uses is UDP. Remember, I referenced the OSI model when we were talking about it being at the transport layer. That's the protocol UDP, how devices communicate, UDP and TCP. But nonetheless, nonetheless, the focus is DHCP, and this is a network protocol that automatically assigns IP addresses and other network configurations. The example I gave was, imagine if you have a thousand, maybe that's too much, but say you have 100 new computers, and instead of manually going to each and every single computer and trying to go ahead and input an IP address, you have a server, okay, or you have a service that of DHCP that automatically goes ahead and configures IP addresses. Okay, so that's exactly what a DHCP does. Okay, file share. So when it comes to file share, guys, there's a lot. Okay, as you guys can see, the most common file sharing, you have your traditional FTP, SFTP, FTPS, TFTP, right? And honestly, which protocol it uses, it's dependent on the application and how the application was programmed and what the intention of the programmer's goal was. Okay, remember we also have web-based HTTP, HTTPS. Okay, WEBDAV network. You have server message block. You have NFS. Okay, so I gave you guys a lot here. The ones that you should definitely know: HTTPS, right? Port 443, because that's Hypertext Transfer Protocol Secure. And then FTP, that's one that they always add in there, even though it is technically older technology because it's not secured. That's one that they always have that there. I might have missed one with SSH, right? Secure Shell port 22, that goes ahead and allows it to have various things. One of those, which is file sharing, which you can go ahead and do so with encryption. It has a layer of security. Okay, let's go to print servers. Okay, so the most common print server protocol, okay, is going to go ahead and be basically IPP. So modern printing protocol is going to be the IPP. If you run into LDP, just make sure that you know that that's essentially old. When it comes to the network, TCP/IP, UDP, okay, and just knowing that, hey, more than likely you're going to run into IPP, but LDP is something that you should keep in the back of your mind if you have, or if you're working with a lot of older hardware, or if they don't want to change the printer because, hey, it's not broken, we don't need to fix it, so to speak. So just keeping that in mind. Print servers, and one of the benefits of having a print server, as opposed to just having the computer attached to a server and having to request. Basically, what I want to say is, when you have a print server, you have a dedicated device that saves resources from other computers. So if you have a printer connected to one computer and you're constantly having to print things, you're technically using the resources from that computer that's connected to the printer. And in order to avoid that, if that's a busy computer, or if it's or what have you, having a dedicated print server can go ahead and save up resources, and it's a lot easy because it's a little bit more centralized, so to speak, with regards to printing. So just keep that in mind. Just IPP. More than likely, if you're working in a big office, you're going to have a dedicated print server. If you're working in a small office where there's 5, 10 people, you might just say, hey, don't turn this computer off, or else you're not going to be able to print, kind of thing. So just keeping that in mind. This brings us to word of the day. All right, guys, word of the day is SCADA, SCADA, Supervisory Control and Data Acquisition. Okay, guys, so this is a big fancy word, and as you guys have already seen, technology is literally invading every little nick and cranny of everywhere out in the world. We as humans love to go ahead and automate things. We like to make things simple. We like to go ahead and basically be efficient, which is a nice word. Okay, which is a nice word for saying, I don't want to say lazy, because lazy isn't the right word, right? It's efficient. A euphemism for lazy, efficiency. So, in other words, when it comes to SCADA, okay, think of automation, but this is on a higher level. Okay, because now instead of having to automate your DHCP where you can get an IP address type of level, now we're automating things that has a higher potential for disaster. Okay. If your program isn't configured correctly and that program is working on oil or gas or water or agriculture, you can see the applications and the repercussions are that much greater. Okay. There's more on the line, so to speak. If your DHCP had a little hiccup, okay, and you got the wrong IP address or you misconfigured the DHCP and now you're giving out different IP addresses, that's not a good day. Okay, that's not a good day. If you go ahead and you have someone hacked into the SCADA and now they're able to control oil, gas, and water, and perhaps maybe mess with it and configure it the way they want it to, that is not a good day. You see how you'd have not a good day and then not a good day? Okay. So the level that you're operating with the SCADA is is honestly more important, right? Not to say that other things aren't, but it's just, hey, and this is one thing that honestly really does interest me, because when it comes to nation states, we already know this. We already know that the United States probably keeps tabs on Russia. Russia keeps tabs on the United States. Now that with China, and basically everyone's hacking everyone, trying to go ahead and get their information. But this is one that is something where it's just like, hey, if you wake up the next morning and you say, hey, we have no gas because it's been shut down and it's been hacked. Imagine the implications of that. Okay, that is not a good day. Okay. But you guys can see what I'm saying here when it comes to SCADA. It's hardware, it's software in an industrial organization to control machines and processes. It's basically a fancy word for saying, hey, we're let's try to go ahead and automate as much as we can into our systems to the things that are necessary. And obviously they do that for obvious reasons. It's just less manpower, so on and so forth. It could probably be it's more efficient with regards to having computers check things and whatnot. But that's something that definitely does interest me, and making sure that we have, at least for this level for CompTIA 8 plus, just knowing what SCADA is, I think you'll be okay. When it comes to higher level security or networking or security plus, you're definitely going to be looking into SCADA. I know I was looking at some jobs, and they actually wanted to have a SCADA operator. Okay, and it was rather interesting. All right, because you're literally focusing, because this you're kind of marrying two subjects. You're looking at the cybersecurity component, and at the same time you're looking at the industrial component. Okay, so what do you know about water, and how is it cleansed, and how many gallons does it need? How many gallons can your filter handle? Okay, so on and so forth. So things of that nature. So it's kind of like the blend of two disciplines, so to speak. But I think I said enough. So, word of the day: SCADA, supervisory control and data acquisition. It deals with hardware and software in industrial organizations. Let's go on to the next thing. So, mail server. We actually talked about this, guys, right? We talked about this on our 2.1. Most common mail server protocols. Sending email was SMTP, Simple Mail Transfer Protocol. Okay, and that was dealing with port 25. And then we had receiving email, which was POP3, and then we had IMAP. Okay, POP3, I believe that was 110, and IMAP, I believe it was 143. Okay, make sure you check me on that one. Let's see here, and then MIME, MIME. Okay, that deals with attachments. So nowadays, everyone and their mother can say, "Hey, when I put an email, I went ahead and I attached that report, or I attached those records, or hey, I attached I attached some pictures with the email." That is a different protocol in it of itself. Okay, so I do want to go ahead and distinguish that at this point. Just knowing that SMTP, POP3, and IMAP are basically protocols, okay, knowing their port numbers, that should be sufficient enough. Going into the nitty gritty nuts and bolts and literally knowing exactly how they work, I don't think we're going to be responsible for that material. If you want to do some research on your own, feel free. Okay, guys, let's continue with web services. This here, obviously, guys, remember, you have the way this technology works, the way they like to label it is client server. Okay, so any device, okay, and they go back and forth. So a client can be a server and a server can be a client. But any device that provides services is considered a server. Okay, and that's pretty self-explanatory. That's pretty simple and easy to memorize. Okay, so that's kind of like what I'm saying here. Server equals services. So, and it just depends on that moment in time and what exactly that device is doing or what the application is configured to do. Okay, so when it comes to web servers, okay, just realize that there's web servers that literally would all they do is focus on just DNS. Okay, that's going to be their DNS server, and it can be done online. Okay, you have websites. Okay, websites. When you have a website, there's a computer on the back end that has its code. Okay, or you might even have it in the cloud, but nonetheless, there's still a computer on the back end that's saying, "Hey, we took this code. We took Java. Okay, we went ahead and we're going to go ahead and have this website look like this." There's a lot of languages that go into making a website, and that's how it would go ahead and as a programmer, you can go ahead and develop your website the way you want it to. Web applications. I mean, nowadays, who hasn't used an app? I feel pretty confident whoever's watching this video has used some type of application. A lot of, for example, Microsoft 365, that would technically be considered a web application because you don't necessarily need to download or install the program. It's something that now that you go onto the web, you go ahead and go onto their website, you type in your username, you type in your password, and voila, you have access to their Office suite. Just remember, when it comes to content delivery, the protocol it is using nowadays, modern protocol would be HTTPS. Okay, we talked about that already. AAA. Okay, AAA. This is something that would be discussed further when it comes to the idea of security, because AAA is a form of security. Long story short, what AAA stands for is authentication, authorization, and accounting. Okay, and basically what that means is authentication is, are you who you say you are? Okay. Are you who you say you are? Okay. How do we know? Well, you have the right username and you have the right password. So technically, you've been there's a layer of authentication there, right? Now, authorization is, hey, just because you have the right username and the right password doesn't mean you're going to get access to all the information that we have on our server. If it's your first day on the job, so to speak, it would not be a good idea to have people who haven't had um, I don't want to say clearances, but if it's your first day on the job, you don't want to give somebody authorization to all your information in your network. That's just bad practice. Okay. So that's the difference between authentication and authorization. And accounting is pretty simple. Accounting is just a matter of going ahead and logging things. So making sure that there's timestamps within the actions that it happened, so you can go ahead and have a log of exactly what's going on within your system. So authentication is, are you who you say you are? Authorization is the level of access of information that you're permitted to have. Accounting is a matter of going ahead and logging. Okay, and this is a fundamental security mechanism, radius and tachus. Okay, this comes a little bit more so when it comes to enterprise, big organizations, and it has to deal more so with security. I think as long as you know the definition of authentication, authorization, and accounting, or if they ask you, hey, which of these would be a security feature, and you see something along with AAA, obviously take the whole question as its whole, um, as its I don't want to say wholesome, because that's not the right word, but just looking at it from the big picture thing, and if this is the only option that provides security, more than likely this would probably be the correct answer, or depending on actually what they ask. But that's what I was initially trying to say. Internet appliances. Okay. So spam gateways. So believe it or not, there is filters out there in the web that literally just go ahead and try to filter email traffic. Google is a perfect example of this. If you go to Google right now, if you have a Gmail account and you go to your Google, you're going to see where it says offers or marketing, things of that nature. And basically, there's like an accounting mechanism, so to speak, that looks at all the IP addresses that are being sent. If they're saying, hey, there's mass mail being sent, or hey, this sender is notoriously known for sending spam, so on and so forth. That's something that's going on in the internet. And that's for your protection to go ahead and avoid fraud and whatnot. UTM, okay, believe it or not, this is something that's really big when it comes to cybersecurity. UTM is literally what would be um, a holistic approach to cybersecurity, because UTM is firewall, it's IPS, it's antivirus, it's VPN filtering. Okay, it's instead of looking at one component as a cell, so to speak, UTM tries to look at all the options when it comes to security and making sure that you basically centralize that the hardware. So if you can centralize your firewall, your IPS, your antivirus, VPN filtering, it just gives you a higher level access of control. Which the repercussion of that is, hey, what's not to say if your UTM is compromised? Now they have the adversary now has control of the firewall, IPS, antivirus, so on and so forth. But nonetheless, notice how there is this consistent theme of getting to a centralized point of controlling devices. Okay. And I think that's happened since the beginning of the IT industry. Load balancers, nonetheless, load balancers, you can have that in hardware or software. And that's basically going ahead and making sure that you have a nice, good, consistent flow. Okay. Load balancers is exactly what it sounds like. It's trying to balance the load. If you have, for example, with AWS, if you have a server and it's getting an enormous amount of requests, and say that they're just because of popular demand, it can go ahead and start to trigger things where it's saying, hey, let's get a new server on here, or that way we can start going ahead and satisfying these requests or things of that nature. Proxy server is actually one of a similar thing, because it's almost like a middleman. Okay, instead of going ahead and consistently going back to the a server, you can get a proxy server which saves things in its cache memory. So anytime it's asking for consistent or regular request, you can go ahead and use a proxy server. This is going to sound like a really bad analogy, but just think of a proxy server, okay, as a popular fast food number, right? So say you like going to McDonald's, you're like, hey, give me the Big Mac. Hey, give me the Big Mac. Hey, give me the Big Mac. It's just McDonald's already has its recipe and it already has its process to go ahead and fastly produce the Big Mac to push out more numbers, so to speak. Not the greatest analogy, but just realize that a proxy server is not the actual server; it is a middleman, and it helps the original server with the original information go ahead and give out and output more information at a faster rate. So we talked about that: spam gateways, UTM, load balancers, proxy servers. I honestly, me personally, I like looking into UTM, okay, Unified Threat Management, because I like the idea of cybersecurity. But nonetheless, just depending on where you are or what you want to do, proxy servers can probably be another good one. In regards to studying it in a more in-depth level. We talked about SCADA. That was literally word of the day: supervisory control and data acquisition. Basically, it allows industrial organizations to control and monitor industrial processes. Okay, I think we talked about that enough already. Hopefully you learned what SCADA is. Remember, try to take at least one thing away from every presentation. And lastly, we're going to talk about IoT. I'm going to be honest with you guys. This thing kind of, I don't want to say it fell flat on its face, but when I started studying this, they made a big deal of IoT. And IoT's kind of been quiet. And it's one of those things that when things are quiet, I'm just wondering, hey, what's going on? Are people liking this idea of having a refrigerator tell them when they're low on milk? Or do people find that too evasive? Or do people like to have a smart coffee maker that is already programmed to make coffee? So on and so forth. And it was pretty interesting because I'll give you guys a quick little story, and it does pertain to IoT. Uh, there was I guess there was a safety mechanism within one of the washers or dryers that I had a teacher of mine order, and she was into the IT field, and she goes, it made no sense to me because one of the things that the washing machine wanted me to do was to be present when I asked it to wash things or when I asked it to dry things because it was a safety feature, which kind of defeats the whole purpose of IoT, right? If you're wanting to control things from a remote location and the device doesn't let you because you're not physically present there, then why would you have that feature? Might as well just press the button that because I have to stand in front of the washing machine or in front of the coffee maker already. So just because we do live in a litigious country, so to speak, and people do get sue happy, I can see why they kind of made that a security feature. And mind you, not too long ago, people were doing pod challenges, where they were trying to go ahead and eat Tide Pods. So, nonetheless, Internet of Things, it's basically going ahead and taking the devices that we use in a daily manner and trying to go ahead and put them on the network and being able to control them from the network. Once again, the idea of going ahead and having centralized control. Okay, it's the idea of putting devices on the network to control and monitor via internet. And that basically does it for us, guys. That is our presentation for what would be 2.4 summarized services provided by networked host. Okay, so mind you, these are not all the services. These are just the bare minimum services that we should be aware of when it comes to the IT field. I promise you, if you get into Networking Plus, because I technically already looked at the course exam objectives, when you get into the Networking Plus, they're going to take this and multiply it and give you a lot more things for you to basically summarize, memorize, and know when it comes to the services provided. But I think for entry level IT, or at least for what would be Comtpia A plus, this should be you should definitely memorize these services and know exactly what they do, realize their port numbers, and be able to troubleshoot, or at least have an idea of how to troubleshoot these services. Nonetheless, guys, with that being said, I will see you guys on the next one.